This is General Chemistry. We continue to learn about stoichiometry, and today we will be looking at chemical formulas. Previously, we learned that stoichiometry focuses on the relationships between reactants and products in chemical reactions. For example, in a reaction between magnesium metal and hydrochloric acid to produce magnesium chloride salt and hydrogen gas. If we know the amount of magnesium metal used in the reaction, we may figure out the amount of the acid needed, the amount of magnesium chloride produced, and the amount of hydrogen gas released. We also learn about mole, which is a basic concept in stoichiometry. Now we know that mole is a central unit, and we can relate it to several other quantities. We can relate mole to the number of atoms or molecules, to the mass of atoms or molecules, to the volume of gas, and to the concentration of a solution. In this video, we will take a look at another basic concept in stoichiometry, and it is chemical formula. Chemical formula is pretty much an identification of a compound or a substance, and it can tell us the chemical compositions of that compound. For example, formaldehyde has a chemical formula of CH2O. That means formaldehyde contains 1 carbon, 2 hydrogen, and 1 oxygen. And for lactic acid, the chemical formula is C3H6O3. That means lactic acid contains 3 carbon, 6 hydrogen, and 3 oxygens. And for glucose, the chemical formula is C6H12O6. That means glucose contains 6 carbon, 12 hydrogen, and 6 oxygen. Here we will be taking a look at 3 types of chemical formula: the empirical formula, the molecular formula, and the structural formula. The empirical formula shows the smallest possible ratio of the elements in a compound or in a substance. But the molecular formula shows the actual numbers of the elements in that compound. And for structural formula, it shows how the elements are connected to each other. So let's take a look at some examples. Here we will be taking a look at the empirical formula, the molecular formula, and the structural formula for formaldehyde, lactic acid, and glucose. For formaldehyde, the empirical formula and the molecular formula are the same. It is CH2O. And the structural formula shows that it contains 1 carbon, 2 hydrogen, and 1 oxygen, the same as in the molecular formula. For lactic acid, the empirical formula is CH2O, which is the same as in formaldehyde, but the molecular formula is C3H6O3. And its structural formula also shows that it contains 3 carbon, 6 hydrogen, and 3 oxygen. For glucose, the empirical formula is CH2O, the same as in formaldehyde and lactic acid. The molecular formula this time is C6H12O6. And its structural formula shows that it contains 6 carbon, 12 hydrogen, and 6 oxygen. In stoichiometry, we will be focusing more on empirical formula and molecular formula. You already probably realize some kind of relationships between these 2 types of formula. Let's say we have lactic acid. The empirical formula is CH2O, and the molecular formula is C3H6O3. And if we look at its molar mass, you can see that for CH2O it is 30 grams per mole, but for C3H6O3 it is 90 grams per mole. So, in order to convert empirical formula into molecular formula, we just have to multiply 3. Now let's take a look at glucose. The empirical formula of glucose is also CH2O, but the molecular formula this time is C6H12O6. And if we look at the molar mass, CH2O has 30 grams per mole, but C6H12O6 has 180 grams per mole. So, in order to convert empirical formula into molecular formula, we just have to multiply 6. In general, if we want to convert the empirical formula into molecular formula, we just have to multiply by a whole number. And this n can be 1, 2, 3, 4 or whatever, depending on specific compounds. Now let's try some practice questions to figure out the chemical formula. For this one, percent composition by mass of an aldehyde is 55% carbon, 9% hydrogen, and 36% oxygen. If the molar mass of this aldehyde is 44 gram per mole, what are the empirical formula and the molecular formula? Usually we will start with this. We will write down carbon, hydrogen, and oxygen because they give us carbon, hydrogen, and oxygen. And then we write down the percent by mass that they give us, which is 55%, 9%, and then 36%. It is pretty much saying that if we have 100 grams of this aldehyde, we will have 55 grams of carbon, 9 grams of hydrogen, and 36 grams of oxygen. So we can put it here. If it is in 100 grams original. So basically, if we divide this by the molar mass accordingly, we should be able to get the mole. So let's do that. So we will divide it 55 by 12 gram per mole. And then 9 by 1 gram per mole. And then 36 by 16 gram per mole. And we should be able to get 4.58 mole. And then 9 mole for hydrogen. And also 2.25 mole for oxygen. But we know that in the empirical formula or the molecular formula, it's usually using the whole number as a subscript. So we have to turn this into a whole number. Normally the way I do it is to divide it by the smallest number first, which is 2.25 over here. So I'm going to do that. So I'm going to have 4.58 divided by 2.25, and then 9 divided by 2.25, and then 2.25 divided by 2.25, and that's gonna give us 1 over here. And then for 9 divided by 2.25, that should be 4, and then that should be about 2. Alright, so the smallest ratio of this compound is 2 carbon, 4 hydrogen, and 1 oxygen. So that means the empirical formula for this aldehyde is C2H4O or O1. And we know that we have to multiply the empirical formula by a certain whole number to make it into molecular formula. And it is 12 times 2 for carbon plus 1 times 4 for hydrogen and plus 16 for oxygen. So that is going to be 44 gram per mole. In order to convert the empirical formula into the molecular formula, we have to multiply N. So that empirical formula and this molecular formula. And we have 44 gram per mole over here. We have to multiply N into 44 gram per mole as well, which is given in the question above. So N is actually going to be equal to 1. That means the molecular formula for this aldehyde is also C2H4O1. This is the answer for the empirical formula, and this is the answer for the molecular formula. Let's try another question. For this one, percent composition by mass of a compound is 24.3% carbon, 4% hydrogen, and 71.7% choline. and the molar mass of this compound is 98.9 gram per mole. So find the empirical formula and the molecular formula for this compound. Alright, again, we will set up each element, carbon, hydrogen, and choline, and it gives us 24.3%, 4% for hydrogen, and then 71.7 for choline. And so if we think of the whole percent as 100 grams of the whole compound, that means it will contain 24.3 grams of carbon, 4.0 grams of hydrogen, and 71.7 of choline. The next step is to convert it to mole. We will divide it by the molar mass accordingly. So here we're going to be divided by 12 for carbon. For hydrogen, it's going to be 4 divided by 1. And then for choline, it is 71.7 divided by 35.5 gram per mole. And that's going to be equal to around 2 mole for carbon. And then about probably 4 moles. Yes, it has to be 4 mole for hydrogen. And then also about 2 mole for choline. And so we can divide this by the smallest number, which is 2 over here. So it is going to be 1, 2, and 1. So that is the smallest ratio of the elements in this compound. So that means the empirical formula for this compound is going to be C1H2Cl1. Okay, so the next step is to try to figure out the molecular formula. And we know that in order to convert that, we have to use the molar mass of the empirical formula multiply certain number going to be equal to the molar mass of the molecular formula. So we need to know the molar mass of the empirical formula first, and that's going to be from CH to Cl. So we're going to have 12 plus 2 plus 35.5, and that is going to be 49.5 gram per mole. Okay, now we can plug this in. So it's going to be 49.5 times N, going to be equal to the molar mass of the molecular formula, which is 98.9. So that is going to be around 2, approximately 2. That means the molecular formula is going to be equal to the empirical formula times 2. So it's going to be C2H4Cl2. Alright, so for the answer here, the empirical formula is CH2Cl, and the molecular formula is C2H4Cl2. So in this video, we learn even more about stoichiometry. We learn how to figure out the chemical formulas, especially the empirical formula and the molecular formula. Again, stoichiometry is really useful topics, and it can be applied into many other branches in chemistry. Practice more until you are comfortable with this, and good luck!